6.6, recursively defined sequences. Now, when we're talking about recursively defined sequences, this could either be arithmetic or geometric. We're going to do both. And we're first going to start with an explicit rule. Now, an explicit rule are the formulas that you've already done. And the explicit rule will tell you any number in the pattern. So, for example, when we did arithmetic, we used y equals mx plus b, which is also that weird a sub n thing. But if you wanted the 25th term in the pattern, you just substituted in 25, and it told you what that number was. Okay, same with geometric. We had the a sub n equals a sub 1 times r to the n minus 1. If we wanted the 7th term in the pattern, you substituted in 7, and it would give you the 7th term. Okay, this is the rule we typically use because it tells you any number you want. Now, a recursive rule only tells you the next number in the pattern. Okay, it will also kind of tell you what the pattern is. So if it's arithmetic and you're adding 5, it'll just say, okay, if this number is 10 and you add 5, then the next number is 15. And then the next number is 20. And then the next number is 25. But there's no way to say what's the 50th number in the pattern and to just get it. Okay, which is why we don't tend to like the recursive rule. Now, recursive rule for an arithmetic is going to be a sub n, that's whatever number you have, equals a sub n minus 1 plus d. Now, the plus d is the pattern. That's the common difference. So if you're adding 5, this is add 5. This little guy right here is the number before the number you're trying to find. Okay, so if I have the first number, then this would be, this is going to be the second number. This would be the first number. It'll make more sense once we do it. Okay, and then recursive for geometric, this is arithmetic, this is geometric, is you're going to take whatever number you're trying to find, the number before, and multiply it by the common ratio. Okay, again, this will make more sense when we look at it. Example 1. Write the first 6 terms of the sequence, then graph the sequence. If we're writing the first 6 terms, 1, 2, 3, 4, 5, 6. Now let's go look at what they gave us. First of all, they said a sub 1 is 0. Because of this little 1, I know that the first term is 0. Then they gave me this recursive formula. I know that a sub 1 is 0. And then they're saying, okay, take the 0 and minus 8. So really they're telling you if we're going to minus 8, that the common difference is minus 8. So I know that this is arithmetic because I'm subtracting, which means it's linear. So if I'm going to minus 8, I take 0, I minus 8. I take minus 8, I minus 8 again. I minus 8 again. I minus 8 again. I minus 8 again. That's the first 6 terms of the sequence, 0, -8, -16, etc. Now we have to graph this. So for my graph, I'm going to set up essentially my 4th quadrant. 1, 2, 3, 4, 5, 6. And then I'm going to do -5, 10, 15, 20, 25, 30, 35, 40. So -5, -10, 15, 20, 25, 30, 35, 40. So our first point is 1, 0. Then we have 2, -8. 3, negative 16, 4, negative 24, 5, negative 32, and 6, negative 40. Okay, try your best. But what do you notice? And to me, I notice these are linear. Okay, specifically linear with a negative slope. So this is arithmetic. Let's take a look at our next one. Set up your table. We have to find the first 6. 1, 2, 3, 4, 5, 6. A sub 1. A sub 1 is negative 7.5. So I know that my first term is negative 7.5. Now, I go over to my recursive formula, which will tell me the next term. Well, the next term, they're saying take the negative 7.5 and add 2.5. So this is a plus 2.5. It says it right there, plus 2.5, which means, again, that's a common difference, which means this is going to be arithmetic because we're adding. So negative 7.5 plus 2.5 plus 2.5 plus 2.5 plus 2.5 plus 2.5. Then we have to graph it. One, 2, 3, 4, 5, 6. And then I'm going to go, let's see, 5. 1, 2, 3, 4, 5. And negative 8. So I go over 1. I go down negative 7.5. I go over 2. I go down negative 5. 3, I'm at negative 2.5. 4, I'm at 0. 5, I'm at 2.5. And 6, I'm at 5. Once again, those look pretty linear to me, and they have a slope of positive 2.5. So I know this is arithmetic. Letter B. Once again, set up your table. One, 2, 3, 4, 5, 6. This time, first term in the pattern, they're telling me is negative 36. Then I'm going to go look at my recursive rule. And this looks a little different because the last two we did, they had like a plus or a minus on them. This doesn't have a plus or a minus on it. It looks like 1/2 times something. So this is telling me take 1/2 times the number before. So I'm going to go here and I'm going to multiply by 1/2. So this is giving me a common ratio, which means this isn't arithmetic. This is probably geometric. So if I multiply by 1/2, I'm going to get negative 18. Multiply by 1/2, I'm going to get negative 9. Then negative 9/2. Then negative 9/4. Then negative 9/8. Okay, those are the first 6 numbers in the pattern, and now we have to graph it. So once again, I'm going to set up kind of a 4th quadrant graph here. 1, 2, 3, 4, 5, 6. And then we have to get to negative 36. So I'm going to go by 5s. Negative 5, 10, 15, 20, 25, 30, 35, 40. So negative 10, 20, 30, 40. Okay, at 1, I'm at negative 36. At 2, I'm at negative 18. At 3, I'm at negative 9. At 4, I'm at negative 9.5, which is negative 4.5. Then negative 9/4 is even smaller, and then negative 9/8 is even smaller. And what do you notice? You should notice that these don't form a straight line. Instead, they kind of look like exponential. Letter D, same idea. Now, pause your video, try to do this on your own. When you're done, unpause the video and see how you did. A sub 1, 0.7. Then on this one, they're saying, okay, we're going to take that a sub 1 and we're going to do 10 times something. So right here, that's 10 times, that's a ratio of 10, which means multiply by 10. So I'm going to take 0.7 times 10, which is 7. Multiply by 10, 70, 700, 7,000, 70,000. Wow, that got big. That got big real quick. Now, graphing that, well, let's see. We're going to have to get really, 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 really big. 1, 2, 3, 4, 5, 6. And we have to get to 70,000. Oh, wow. Why don't we count by 10,000? So 10, 20, 30, 40, 50, 60, 70. So this is 10,000. This is 20,000. This is 30,000, etc. Keep going. Okay, so at 1, we are tiny. Like, I don't even know if that fits on the graph. 2, we are still tiny. 3, we're at 70, which compared to 10,000 is tiny. 4, we're at 700. 5, we're at 7,000, which is kind of getting near that 10,000. And then 6, we're at 70,000. Oh my heaven. That's a lot. So once again, exponential, because that exponential growth is just going to take off.